going on over there? Okay, so yesterday we left off talking about economizer systems, also called a power enrichment system that enriches the mixture above 60 to 70% power. And why do we want a richer mixture above 60 or 70% power? For cooling and anti-knock detonation. Okay, so there are, well, we'll talk about 4 different types. Of economizer or power enrichment systems. So one is the needle type. A needle type is where, as the throttle is open, a second jet, a jet in parallel with the primary jet, is opened up. So you open up a whole new way for fuel to get through, which then allows you to sort of bypass the main metering jet and add more fuel. And so you automatically enrich it. Not automatically, but yeah, automatically. So as the throttle is opened, a second jet is opened, allowing more fuel to the discharge nozzle. We have the piston type. I'm going to show you some picture of these too. We'll stop right there. We'll just look at the picture here. So needle type. Mixture controls. Let me see if I got one here. Here we go. Needle type. So as the throttle is pushed forward, opening this up more, normally you'd have fuel coming from the, over here, the float bowl through the main metering jet, over here, up and into here. But when this opens up, it creates a second passage out of this little well right here that bypasses the main metering jet that would be over here and allows it to just run right up through here. So more fuel.
How does fuel get in there?
In here, it's part of the float bowl. It's already there. Airport, let me see if I have a piston. No. Oh, I don't have a piston type. Piston type. It's very similar in operation to the needle, but uses a double piston. Similar in operation to needle, but uses a double piston. So the way it would work in cruise, I'm not going to make this so complicated. I'm just going to say that, until I find a picture for you, because I know I had one. Basically, this is another way of adding more fuel. And it's going to be tied in directly to the throttle. So as you move the throttle, it's automatically going to move this double piston inside of the carburetor, and that's going to realign some passages, and it's going to just shoot more fuel in. So it's pretty much doing the same thing. I think we can keep that a little more simple than I was going to do it. Manifold pressure type. what this is going to do, it's actually going to work off of the manifolds. It's going to sense manifold pressure. Now, manifold pressure, again, is from the throttle valve up to the cylinders. So as I open the throttle, what happens to manifold pressure?
It decreases.
Am I going to get more suction or less suction? Less suction. So what is, generally speaking, about the most manifold pressure you can have in a normally aspirated aircraft?
29.
About 29. Well, it's really about an inch less. So what is an atmospheric pressure? 29.92. It's called 30. So what's about, so if you have an inch less, what's that?
No, it's called 30.
I said, let's just call it 30, right? See, because it takes too long to say 29.92. Now I can just say 30. And look at all the time I just saved by saying 30. Thank you for ruining it all. All right. So manifold pressure, when the engine's off and I get into an aircraft with a manifold pressure gauge, what should it read?
30.
Ambient pressure, which is
30.
29.92. Come on, guys. So it's 29.92. And as I start up the aircraft at an idle, what is that manifold pressure going to do? Is it going to go higher? Is it going to go a little bit lower or a whole bunch lower? Okay, it's going to go way lower because we have a massive amount of, now we got a lot of suction. Okay, now as I advance the throttle, what's going to happen? Is it going to get more suction? Less suction. It's going to go closer to ambient until I get to wide open throttle, and it'll be close to ambient, maybe an inch less. Why an inch less?
Because for the losses.
Losses from the Venturi, losses from the air filter. Then as I start rolling down the runway and the aircraft picks up speed, what's going to happen to manifold pressure? It's going to increase a little bit. If you have a fixed pitch prop, it'll increase because RPM is going to go up too at that point. Okay, so manifold pressure type.
By the way, when your engine fails, it's the only thing that goes up.
Oh, yeah. Bad news is the engine quit. Good news is I'm making more manifold pressure than I ever did before.
It's the only thing that goes up.
I'm sorry that you know that. That's not a good thing. All right.
From 11 to whatever.
What does MAP mean?
Manifold absolute pressure.
Manifold absolute pressure is increased. A sealed bellows collapses. And allows a valve to open, which adds fuel to the discharge. This really sounds like something we're going to see next week. So what does a sealed bellows do? Well, I don't think I can draw bellows very well, but I'm going to give it a shot. But symmetrical. All right, so if we have a little accordion thing that collapses and expands, and I fill it full of an inert gas, and I seal it up, all right, and what happens as I take something, so I seal it up, and it's kind of at a medium length. It's got some curvature to it. And what happens is I take it up in the atmosphere. It's going to expand, and if I take it and I go down into Death Valley or take it in the swimming pool, the bottom swimming pool, it's going to collapse. So what it's doing is it's sensing atmospheric pressure. So it's just a simple way to sense atmospheric pressure. And so you can actually calibrate it and fill it so it's a certain length at 30 inches, 29.92. And that way we can actually get a calibrated device that'll open and close all on its own based upon atmospheric pressure, or in this case, the manifold pressure. So we're going to be seeing a whole lot of this sealed bellows. We're going to see it with turbochargers. We're going to see it with this manifold pressure thing. We're going to see it with pressure carburetors. So you're going to kind of get used to seeing that. Go, okay, now I know how that works. And then we have 4, back suction. What carburetor has the back suction type?
This Marvel Shebler.
Okay, Marble Shebler does. That you know of. Maybe more that will work at. In cruise power. So the Marble Shebler, and that's what I was thinking, is that that's not automatic, of course, that's manual, but that's all right, we're talking about that. In cruise power, a vacuum is applied. I should say, I'm going to take away in cruise power, and I'm going to say, no, that was fine. Make it like that. Cruise power. Because do I really want to be leaning a whole bunch at max power? No. Okay, so in cruise power, vacuum is applied to the float bowl. And if I add a vacuum to the float bowl, what is that going to do? What is that giving me?
You're going to equalize the pressures between it and the Venturi.
All right, so I equalize the pressure or lessen it between the Venturi and the float bowl. What happens if the pressure in the float bowl and the pressure at the Venturi are totally equal?
You get no
Uh,
fuel.
There's no fuel, no fuel.
Okay, when is it totally equal?
Off.
Off.
Off is correct. That's what I was looking for, not idle. Off. When the airplane is off, is the pressure at the Venturi the exact same as the pressure in the float bowl?
Yes.
And how much fuel flows?
0.
That's because they're equal. Right? That's pretty much the only time. So, well, okay, you did say idle. You have to think about that. He's right. Because at the Venturi, it is at idle. Sorry. But right above it, it's obviously not. But does any fuel come out of the discharge nozzle at idle?
No.
No, because it's
Same.
the same. It's the same. So good job on the idle thing. Float bowl. So let me see. What did I say? In cruise power, vacuum is applied to the float bowl, which lowers the fuel. Oh, that is not right. Which I don't like that. Which lowers the we'll say pressure in the float bowl. Yeah, I don't know where I saw I'm reading my notes. I don't like it. I'll tell you what it says. I wonder what book I got this. In a cruise power, vacuum is applied to the float bowl, which lowers the fuel level at the discharge nozzle. There's a danger with saying that. And what is the danger? What's that? The fuel, what? It does. It's the amount, not the level, because what I hear a lot of is people say, well, when you put a suction in the float bowl, it moves the float. And so I don't want to do that. I don't want you to think that. No. And I put another note here, I believe. So, according to the FA textbook, as the throttle is open and the pressure in the manifold is increased, so is the pressure on the fuel in the bowl. We're just going to leave that up. All right.
I have a question.
Yes.
I think we may have already gone over this, but cruise power
Uh-huh.
is 75% power.
About below 75.
Below 75.
Or it's right around 75. So some manufacturers are more like in the 60 range. Some go 75%. But once you start going over 75, it's considered outside of cruise.
Okay.
And I said 4, but I have 5 here. And I have an air bleed type. I'm going to throw this at you. The airport type, which, I know what I mean. Hang on. I know what I'm going to do with air bleed type. Let me think here. Bring this up. Economizer. Yeah, I'm gonna put this in here. That makes more than 5, but I'm gonna go with this one. There's an air bleed type, and let me see. I don't have it in my notes, but I have it in my head here. At partial throttle, partial throttle, which you have sometimes at partial throttle, there'll be a passageway that kind of lines up with the throttle. And what happens in this range, I'm probably not drawing it quite right, what's going to happen right here? Venturi effect. And so I can take this suction and apply it to the float bowl. And if I apply that to the float bowl, what's going to happen?
Leans.
It's going to lean it out automatically. So we can look for something like that to happen. And I probably drew it in the wrong way because I want it to go in such a way that it's subjected to more suction, even at lower settings. And then once the valve comes down to here, see, we're still going to have it. I should have drawn it the other way. I knew it wasn't right.
Just suction starts
Yeah.
at that dot there.
Let's try it this way. There we go. Just draw it lower. Okay, so okay, so we still have the same thing. So we have a Venturi effect, and as the throttle is closed, it's subjected to low pressure. As the throttle is opened, it's subjected to low pressure. When the throttle gets up to here, it becomes ambient. And so if this becomes ambient, what's going to happen to here? Then this becomes ambient. So you can see how by where I can put this little air bleed type, if I put it in the right spot next to the throttle plate, I can automatically add suction to it during certain ranges of operation, and I can take away that suction during certain operations. So if I take away the suction, then this becomes more like ambient. If I add suction, then I get more of a differential between that and the discharge nozzle, and that automatically leans it out.
Would that be something like when you were drawing the chart yesterday about like manufacturers, whether it's how rich it leans as you're going all the way open, or how lean? Would that be something like the engineer would put in there to automatically?
Absolutely. Absolutely. So.
But that's meant to be an economizer, right?
Yep, that would be. I'd call that Economizer System, in my vernacular. So part throttle and orifice. Will lower the pressure in the float bowl, leaning the mixture in the cruise range. Unofficially, even though I wrote it, this is me unofficial. There is what I would call the float level type. And I think I saw a picture. As the aircraft climbs, if this is set up in the right attitude, and let's see, here's the needle right here. The discharge nozzle, the main metering jet is down in this area. What happens to the fuel level over the main metering jet and in the carburetor in relation to the discharge nozzle?
The level changes.
The level changes. What if the level goes up? Does that make it richer or leaner?
Richer.
Richer. So I think it's possible that some carburetors are actually designed that way, and people kind of forgot this. Maybe I'm wrong on this, but it's food for thought, right? So maybe look at your Stromberg. And your Stromberg, you guys have it now. Think about, and I can show you which way it goes. It actually goes with the mixture towards the back. So think about as it goes up and the float changes and you get a little higher fuel level, that gives a little bit higher fuel level in the discharge nozzle. Would that enrich in your carburetor? Okay. Why would I want it to enrich in as I did this?
More power.
More cooling also.
What happened? When is the airplane doing this?
Climbing.
Climbing. So where's my power setting?
Full power.
Full power. So there we go. So, if an engineer thinks it through and says, hey, wait a minute, when are they going to use full power? They're going to use full power when they're climbing. What if I just change the float level so it gives it a little bit extra fuel because of the way the float is setting in there, and it goes just a little bit richer? Would that work? That'd work.
Wouldn't the same thing happen if you were descending?
Don't ruin my theory. Now it goes the other way. Goes the other way.
Yeah, but wouldn't it still be?
It's going to go that way. This is lower. So if here's if here's the main metering, and I'm looking at the distance between here and here, which is more?
Would it lean it out?
That would be during landing, and this would be during takeoff. Now, I'm not saying it's right. I'm just saying could be, right? All right. Just something to think about. As the aircraft.
Oh, you can't say that.
Nose is up. Float level is higher. All right, let's talk about the mixture control system. Did it again. System. All right, why do I want a mixture control system?
To be able to lean.
To be able to lean. Why do I want to lean? Why is this such a big deal on an airplane?
Because you
The
increase
car doesn't have one.
altitude and temperature change.
Okay.
I think
what?
actually car has it.
I know, but
They
it
have it all in that map.
doesn't have a manual one.
Because they don't trust
Because
it.
they did automatic ones a long time ago.
Did they? Did they have manual ones a long time ago?
I think like back in Model T days, maybe.
I don't think they did. I just think they did have the spark. You had to do your own spark. But all right. So, but why is it a big deal on an airplane? Why do we want it? Well, what'd you say?
To lean out to make sure.
To lean on the mixture because
Altitude change.
the airplane is supposed to go up in altitude. All right. So it's supposed to go up in altitude. As we get up in altitude, what happens to the air? There's less of it, weighs less. Carburetor doesn't know it, so the carburetor keeps putting out the same amount of fuel. What happens to the power at that point?
Starts to choke on.
Power starts to go down. All right, so we want to have some sort of mixture control system. Why? Because as altitude increases, air what?
Air gets thinner.
Has less pressure. Has less density. Does has less temperature. Is that a good thing or a bad thing?
Good thing.
That's a good thing. All right, so two bads and a good. But that's what we have. All right, well, let me see. All right, so what are our problems here? We have many of them. As altitude increases, what happens? All right, we're talking about our engine here. We have less air available for combustion. Does the Venturi work though?
Yeah.
It works, but is it compensating?
Nope.
Okay, the Venturi works off velocity and does not compensate for density. So as the air, let's say, thins, the same amount of fuel is still added. Is still, what did you say? Added to the engine. All right, so here we're going up, going in altitude. Carburetor is not that smart. Well, it's actually doing a pretty dang good job measuring the air, setting the fuel to it, but it just doesn't really understand that the air isn't as dense, meaning there's less oxygen, but it's still getting the same amount of fuel. So we're going to do what again? So we're gonna go rich or lean as we go climbing up.
Oh, rich.
We're gonna get rich as we go up, and that means what to our power? Decrease in power. What happens to fuel consumption?
Yeah,
Lower
unburned
decreases.
fuel.
A lot of unburned fuel. We don't need that. You're just wasting money out the tailpipe. As I mentioned, though, it's kind of funny that most pilot operating handbooks for smaller planes, carburetors, you guys are already seeing it now. It says not to lean below what?
5,000.
5,000 feet. But you can. There's nothing wrong with that. At 18,000 feet, which, by the way, if you're up at 18,000 feet, you probably will not see me in my Cessna 150.
You sure?
I'm pretty sure, yeah.
If it's IFR rated, I guess you could.
No. No, I don't think you would get that. I don't think you'd get that high. Think you'd get that high?
On a really cool day,
If I had all day to get there. Flying along like this. Let's see. At 18,000 feet, an engine needs about 1/2 the amount of fuel as sea level. It's quite a bit.
Yeah, because at 18,000 feet is half of the air.
Mixture control has two functions. I'm going to put the fun in functions. What do you think they are? Guesses? Adjust is the first word.
Adjust the mixture.
2.
Richardly.
Yep, adjust the mixture to compensate for altitude. And economize fuel flow at cruise. So even if I didn't go up that high and I don't want to waste a bunch of money in fuel, I could always pull back the mixture, lean it out. If I am leaning it out, which gauge do you think I would be looking at? EGT is the answer I was looking for. I could do RPM. There wouldn't be anything wrong with that. As I'm doing RPM, what am I looking for though?
peak, and then go, I don't know, depending on what your manual says, but most of the time they want you to go 50 to 100 RPM
Okay,
rich off peak.
peak plus about 100 RPM peak. Or if I'm looking at EGT, what might I want? What don't I want? Okay, if I go peak, what's my problem? Yeah, I'm not as worried about that. Where's my cylinder head temp really going to be the highest?
50 RPM.
Not RPM.
Or sorry, degrees.
50 degrees
Rich.
of peak.
UGT.
That's right. If 50 degrees rich. Yes, we go to peak, and then we enrich it at 50 degrees. That's going to move the curve over to where the cylinder head temp is the highest. So yeah. So yes.
So if you use the where would that be on RPM scale? So if you do take peak RPM and then go 50 rich, where does that put you?
My guess, probably 50 degrees rich of peak. Why do I say that? Because most books say to go, most POHs say to go 50 degrees rich of peak. So they're saying that, they're probably saying that, and the two are probably very correlated. So that's why I put that gauge in my airplane, so when I have time, I can actually experiment and figure all this out. Haven't had a chance to. Let's see. There we go. 3 types. We'll see if I really stick to the 3. Back suction. What carburetor uses the back suction? Yes. Stromberg NAS-3 uses this. And we talked about that. We'll go back around and talk about it a little bit more. All right, so suction. Let's see. Suction is applied to the fuel bowl from Venturi. Actually, just above the Venturi, but so we'll say Venturi area. And when the mixture control is in the rich position, bowl is vented. What's it vented to?
Atmosphere.
Yep. And when the mix control is in the lean position, bowl is vented to the what? Venturi. I'll put Venturi suction. That way you are correct. Needle type. Who uses a needle type? You know what? I'm going to call it something just a little bit different. Needle valve. I like that word better. Needle valve type. Who uses that one that you're familiar with? Yeah, way to go. Wait till I get the first word written down.
Mm-hmm.
Marvel Shubler. All it's doing is it uses a valve to control fuel to the main metering jet. Once the valve is closed, oops, out of room, more than the main metering jet. I'll say main jet. The valve does the metering. So in other words, you have this little valve in there. Well, that's what I said. Little valve. And the valve actually has a positive shutoff. So I can go all the way to full rich. So if I'm in full rich, what's doing the metering? The orifice, the main metering jet. And as I pull back on the red knob in the cockpit and it starts to move that little valve inside the carburetor, the hole is going to get smaller and smaller and smaller. And as it gets smaller, it's going to get to the same size as the main metering jet, which still leads to the same thing. So that's main metering jet. Then it gets a little bit smaller. Now it's going to start leaning. And what happens if I pull all the way back on that?
Idle cutoff.
Then I actually close that off. And if I close that off, no fuel gets to the main metering jet. No fuel gets to the main metering jet. The carburetor
Stops working.
dies. So, and then which knob is that?
The idle pressure?
What color is that one?
Red.
Red. So I won't name names to embarrass anybody, but somebody I fly with often, when I say, okay, we're even with the numbers, go ahead and pull carb heat because we're coming in for landing, and she grabs the red one and says, this one? I'm like, no! Because why does that freak me out if you pull the red knob all the way back?
Show the engine, kill the engine on high.
Because I'm going to learn what the manifold pressure does when the engine's dead really quick, and I don't want to do that.
Well, at least you will get a little RPM rise.
Yeah, but will I? Because it wasn't at idle, so that might have been. All right. I'll make a point over here. Let's see, where am I at? We'll do this. Much better control. And allows positive fuel cutoff. Because, oh yeah, it will stop the engine. And we have the airport type.
The kind that can only be used at airports.
It's only be used at airports. That is actually correct. Valve opens and closes past the Venturi. When open, air enters the manifold. So what happens if I introduce air inside of the manifold on the other side of the Venturi?
You lean it out.
Why do I lean it out? I'm adding air.
You're adding air to more air to the same amount of fuel.
That's right. And I'm adding air on the other side of the Venturi. And the Venturi's job was to do what?
Take air.
Measure. Its job is to measure the air and add fuel. So if I'm adding fuel in a spot where it wasn't measured, then that means that it's going to be
Unmeasured.
lean. If I add fuel in another spot, then it's going to be rich. So if I'm going past the little Venturi, which I've said is the analog computer, then everything's off. So when open, air enters the manifold. So really I'm just adding a bunch of air. Lean it out. Hey, what the heck, right?
Do you get more power? Do you get the same amount of fuel and more air?
Well, you're going to be leaner. Depends. It's, same as everything. You wouldn't necessarily get more power because if you went lean and you were on the lean side of the power curve, then no, you won't get any.
If you had both, yeah.
But if you add more air to it, then yes. That was a joke because if you add air and fuel, that's just making more RPM. When closed, let me see. Only air from Venturi is added. All right. Not really a type of a thing, but I want to explain what this is. Idle cutoff. So idle cutoff is when you grab the mixture control, which is what color?
Red.
Red. Okay, and I grab the mixture control and I pull back on the mixture control all the way back. That is known as idle cutoff. Does it? But the question is, it's called idle cutoff because it's designed to do what?
Cut off the engine at all.
Cut off the fuel at idle, but it works through the entire range of the carburetor. So if you're wide open throttle, we can call it a wide open throttle cutoff just as well. I don't know why they named it that, but it's the position in which the mixture control shuts off I'll say cuts off all fuel to the engine. And the engine will die. All right. Why would they make such a thing? And doesn't that seem dangerous to have a knob in the airplane that if you accidentally pull this knob instead of the carb heat knob, you will shut off the engine? Yeah.
Flying is dangerous.
You want to save fuel?
You want to save fuel. You really can. And that's probably what happened. They were in a meeting and some guy said, I'm so sick and tired of these pilots complaining about how they want to save fuel. I'm just going to make a thing that shuts it off and see how they like that. All right, first of all, safer to use than the ignition. I would much prefer somebody shuts off their aircraft with the idle cutoff if they're bringing it to me to work on than with the key. If I shut off the key, let's think about what happens, which is, by the way, what you have to do with the Stromberg. So I shut off the key. The propeller is going to go just a little bit more. And the propeller's going, so that means the engine's going, which means the pistons are going, which means the air pump is going. So the air pump is going, drawing fuel through the carburetor, and what's mixing with it? No, air is going through the carburetor, and what's mixing with it? Fuel. Yeah, air was mixing with the air. Very good, people. So I have 2 more rubber bands. Not afraid to use it. So fuel is going in, but it's going in the cylinders, and is there spark?
No.
So what do I have inside the cylinders right now?
Unburned fuel.
Unburned fuel and air at just the right mixture. So if somebody inadvertently were to add some spark, what if there was a hot spot in there or something? Or anyway, there's a mixture in the cylinders that's lethal and ready to burn. Don't like that. So if I pull the idle cutoff, I shut off all fuel to the engine. So what's left in the cylinders?
Air.
Just air. Some manufacturers or books I've read actually state that the best method to do it when you shut off your engine is pull back on the mix and pull forward on the throttle at the same time. Open the throttle plate wide open. Why would I want to do that? What?
Take all the fuel away.
Pretty much, yeah, it's pretty close. That's right. If the throttle plate is closed, how much air is getting through? Not a whole lot. Remember that. But if I open the throttle plate all the way, boy, all the air just flows through real nice, and it just really blows and cleans them out. So that's pretty much how I shut my aircraft off. You'll see me pull the mix, and then now you can't do it too fast because you're adding fuel, and it just gets kind of crazy. So you got to wait for it to actually be dying, and then do that. Let's see. Safer to use. Well, why is it safer to use? We can write this. All fuel is burned up. And then we'll say no risk of kickback.
Kickback?
That's when the propeller goes backwards the wrong way.
Hey, Kevin,
Yeah,
if you had the piston type accelerator on your carburetor,
I do.
and you did that,
Huh?
could you keep the engine running by accelerating the throttle?
Yeah, you can. So if you're not careful, that's a good thought. You will do it. If you push hard enough and fast enough, that's on the other side of the mixture, so you could actually get it to go. You keep going with it. Let's see, what did I say? Put when, what did I write? When ignition is turned off. That doesn't make sense. Let me say no risk. I'm not even sure about that one. I have to think about that one. But I like this one. Allows the pilot and mechanic to check idle air mix. What do I mean by that?
To check if there's a rise.
Yeah. So when I do this and I pull back on the idle cutoff and I kill the engine, what should I see the RPM do?
Rise
Rise
20 to 50 RPM and then shut off.
Yep, hey, 25 to 50 RPM rise, then die. And what it was doing is it was just running right through best power. So it hit that rise and then it leaned out very rapidly from there until it died. Just got a few more points here. Some aircraft carburetors actually have an automatic mixture control. That's an O. And that means that you don't have to touch the red knob. You just let the automatic mixture do all the work. So we'll just say with the use of a bellows, all three types of mixture controls not with an E, can be made automatic. And how does that work? You just have to plumb it in the right way into the right ports. As you go up in altitude, it's going to expand. You can make that block off a port. You can make it open a port. You can do however the designer desires to do that, and you can make it an automatic. And you'd also make it you would not get rid of your manual. You would also keep that at the same time. So I can just say that.
So if
All
the
right.
automatic mixture control fails, you could use the
Yep, absolutely. And what happens if the bellows gets a hole in it?
Then you
It
have
goes
to use
by
it.
the money.
Then you lost your automatic. Doesn't work. Gets a hole in it. So we're going to see a lot of things coming up with this bellows. And there's a lot of Q&A questions about bellows. And they'll ask, and what happens if it has a hole in it? The answer is, it doesn't work. So just imagine, what was this supposed to do? Well, I didn't do that. So I'm going up in altitude, and I have an automatic bellows, and it has a hole in it. So the carburetor is going to run what as it goes up?
Rich.
It's going to run rich, because that's what it did, without it. So it just doesn't work anymore.
So, I mean, the pilot has to think.
Yes, but they're busy thinking about other things. So anyway, well, let's take a break.